Hello class, today we're going to be learning lesson 6-2, which is learning how to solve linear systems by substitution. In yesterday's lesson, we learned how to solve linear systems by graphing both of the lines in this linear system. And we found a coordinate, and we knew that that coordinate was the solution for this linear system, okay? So what we're going to do today is, instead of graphing them, we're going to do some algebra, and with the algebra we're going to be doing a lot of substitution. We've done this before where you've had maybe y equals 3 and you plug it in wherever you see the y, you'd plug in that value of 3, but instead we're going to try to just get rid of one of the variables, and we'll do that by substitution. What you want to get first is one variable all by itself and everything else on the other side. Well, looking at this first equation right here, I already have the y all by itself. So what I'm going to do is plug that into the second equation right here. I'm going to substitute it where I see the y. So from here, I'm going to rewrite it x plus 2, and now I'm going to input the 3x plus 2 in place of the y, and that is equal to 11. So do you see what I did? I put what this y was equal to, and I replaced it where the y was, which is 3x plus 2. And then from there, you're just going to finish working it out to get the x all by itself. So 2 times 3x is 6x. 2 times 2 is plus 4, and that equals 11. I'm going to combine my x's now. 1x plus 6x is 7x's. Plus 4 is equal to 11. Now I'm going to get rid of the lonely number, which is the 4. I'm going to subtract 4 on both sides. You've had a lot of practice with this, with getting the variable all by itself. And 11 minus 4 is 7. One more step to get the x by itself. I'm going to divide both sides by 7, and x is equal to 1. Okay, so in my coordinate for my solution, I have the x value. It's going to be 1. I'm still looking for that y value though. So what you're going to do is you're going to take this and just plug it back in. I can choose whichever one of the two equations that I had at the beginning to plug into. So I'm actually going to use the first one. The y is equal to 3x plus 2. And I'm going to plug in the value of x equal to 1. So again, y is equal to 3 times 1 plus 2. That's the same as y is equal to 3 plus 2. And y is 5. So now I can put this up above. So my coordinate, which should be my solution, is going to be 1, 5. It's always good practice to check though, because I may have made a mistake somewhere. So what I'm going to do is I'm going to plug it in to both of my equations. I'm going to rewrite the first one. Y is equal to 3x plus 2. Let's plug in the 1 and the 5. So the 5 is the y, the 1 is the x. 5 is equal to 3 plus 2, and that's true. 5 does equal 5. So it's good for the first equation. Let's just double check to make sure that it's good for the second one as well. The second equation was x plus 2y is equal to 11. We're going to plug them in. The x is 1 plus 2 times the y is 5 is equal to 11. This is the same as 1 plus 10, and that in fact is 11 as well. So I was very successful in finding my first solution for solving these linear systems just by doing some substitution. All right, I found my final solution was the coordinate 1, 5. So let's look at another one. The second one looks very similar. I have two equations. I have x minus 2y is equal to negative 6, and I also have 4x plus 6y is equal to 4. Now neither one of them have the form of just one variable on the left equal to everything else on the right, and so I'm looking to see which one would be better to actually rewrite it, and I'm thinking that this first one is the one that I want to rewrite. Now, the last one, I had y equals everything else, but this time I'm going to rewrite so that I have x is equal to everything else. So to do that, I'm going to have to add 2y to both sides. And then I'll have x by itself. So x is equal to 2y minus 6. From this point, I can plug this in to where I have the x over here. So I might highlight that just so that you can see that. So I have x equals 2y minus 6. And in the second equation, you're going to plug that in. You're going to do some substitution and put it in where you see the x. So let's do that now. So I have 4 times now the x in parentheses 2y minus 6. If you make one mistake, it's probably going to be forgetting the parentheses. That's very important. Plus 6y is equal to 4. Let's work this out. Do the distributive property. 4 times 2y is 8y. Minus 4 times 6 is 24, plus 6y is equal to 4. Again, I want to get the y by itself this time, so I'm going to add 8y plus 6y is 14y, minus 24 is equal to 4. I'm going to get rid of that lonely number, which is the 24, by adding it to both sides. Then I'm left with 14y is equal to 28. One more step, divide top and bottom on the left, and the right hand side, both of those by 14, and I'm going to get y is equal to 2. So I have now found my y, so my final solution, I found that my y was 2. So let's try to figure out what the x would be now. I'm going to actually plug it into this top one up here. So x is equal to 2 times the y is also 2 minus 6. So x is equal to 4 minus 6. And that leaves me with x is equal to negative 2. So I have found the x value now in my final solution for my coordinate. And just like I did before, let's check it out. Let's see if this coordinate is in fact a solution for this linear system. So I'm going to plug it into the first equation, which was x minus 2y is equal to negative 6. The x value is negative 2 minus 2. The y value is positive 2 is equal to negative 6. Be very careful with all of these negatives now, that you don't make any mistakes. I have negative 2 minus 4 is equal to negative 6. Negative 2 minus 4 or plus negative 4 is the same as negative 6. And that is true on both sides. Let's try it with the second one. I have 4x plus 6y is equal to 4. I'm going to plug in the x value, which is negative 2, plus 6 times the y value, which is positive 2, equal to 4. This is negative 8 plus 12 equals 4, and 4 does equal 4. So I successfully showed that this coordinate was a solution for these linear systems. So I hope that this is actually pretty straightforward for you. So I'm going to leave you with your own problem that I'd like you to solve for homework and try to come to class. So make sure that when you come to class, you have isolated one variable. I'll give you a hint. I would try to get the y by itself. That might help you out. And you're going to do some substitution, and you're going to end up getting your coordinate. And then also do the check. Plug in that coordinate into the first equation, plug it into the second equation, and see if you did in fact get the correct solution. So come to class with any questions. I'll see you when you get there.